In the previous video, I defined power series. Inside the radius of convergence, these are functions. That means that all of the arithmetic and properties of functions can apply. So let me talk about some of these properties. First, series with the same center point can be combined by linearity within both of their radii of convergence. So if I have two series with coefficients Cn and Dn, then their sum is a series with coefficients Cn plus Dn. Their difference is a series with coefficients Cn minus Dn. Again, this only works inside both radii. And this only makes sense. In general, if I want to add or subtract two functions, well, that only makes sense inside the domain of both. Domain here is inside the radius of convergence, so inside both radii is just within the domain of both functions. Functions with the same center point add and subtract nicely, but multiplication is more complicated. Power series are like polynomials, but they just keep going. Well, to multiply two polynomials together, I need to FOIL out all of the pieces. And unfortunately, I have to do the same for series, which is miserable since there are now infinitely many terms. The product starts like this. The two constants multiply to give C0 D0. Then the constant from one and the x coefficient from the other gives C1 D0 plus C0 D1 times x minus alpha. Again, I get these two terms from distributing all of the multiplications, FOILing everything out. For x minus alpha squared, there are three combinations from all the distributing multiplications, and then it just gets more complicated after that. And in short, there isn't a nice easy way to describe this. Sometimes I'll still have to work with these products, but it's not particularly pleasant or convenient. Then I can also divide two power series. This is even worse than multiplication, and I'm not even going to start to describe the coefficients. It is possible, at least when the denominator function is not zero, but it is very confusing to express in terms of the coefficients. So addition and subtraction are nice, multiplication is possible, and division is really miserable to calculate. Not a great start for series as functions. But now let me move on to the properties of calculus: continuity, derivatives, integrals. Here the story is actually very good. First, here again is that general form of a series. It has a domain which is determined by some radius of convergence. And the first good news: power series are always continuous within their radius of convergence. So nothing to worry about with continuity. And the next good news: power series are always differentiable. In fact, any number of derivatives can be calculated. And the notation for this is C infinity. This is the class of functions that can be differentiated any number of times. All power series are in this class of functions. So I have continuity and differentiability. That means derivatives and integrals can be calculated, but how are they calculated? Well, think about the derivative or integral of a polynomial. These are all done by linearity and power rule. Each term is done separately, the constants stay the same, and the power rule does the derivative or the integral on the powers of x. One of the best things about power series is that this all still works. Even though the sums are infinite, linearity and power rules still do everything. The derivative of a series has the same coefficient Cn, but the power rule changes x minus alpha to the n to nx minus alpha to the n minus 1. Notice that the starting index is also changed. N equals 0 is the constant in the series, and the derivative of the constant is 0, so that goes away, and now after the derivative, the new series starts at 1. Integrals are just as nice. I just integrate each power. X minus alpha to the n becomes x minus alpha to the n plus 1 over n plus 1, and then I add a constant at the very end. This is one of the main reasons that power series are so valuable. Their derivatives and integrals are all very easy to calculate. Over the last two courses, you've all seen how difficult derivatives and in particular integrals can be. When I have a power series, most of that difficulty goes away. Integrals and derivatives are both really quick and straightforward. And this is, of course, a huge advantage, and hopefully gives you all some motivation for why mathematics might care about this type of function.